Okay, guys, get your servers running and open up your workbench and copy some files from Blackboard. So on Blackboard under weekly learning, class scripts 2018, you'll find a file called joins and subqueries.zip. Right? It's a zipped file, has 4 files if I'm not mistaken. Just download it and extract them and we'll start working on them over the weeks. So let's see how many I can complete today. So I'll let you know what we are doing now for the next 4 weeks for sure, so that you have an idea of what's going on. So till date, we have covered the basic CRUD for a database. That means you can create a database and a table. You can read or select from a table. You can update the contents of a table, and you can delete the contents of a table. So you've covered those 4 operations. Plus, of course, you've done how you can alter the structure of the table by using various adds, modifies, and change columns and so on. Adding a primary key, adding the unique constant, and so on. So we've done the basics of a database, introduction to database course. Now, of course, we have to move a step ahead, right? We all know that a database will not always have only a single table in it. If you think of it, as soon as you start writing an application, even something for Georgian College, for example, what will you do? You will start thinking about the entities at the college, and those entities will be basically, if you can kind of think of it, students, right? One of them will be students, one of them will be professors, non-teaching staff. There could be academic staff at the registrar's office. That's another group. Then you have your CEOs and deans and associate deans. There are another entities. We're all employees, but we are still kind of different because I teach, the associate dean doesn't teach, right? So as soon as you start thinking of an application, you will almost always require more than one table to represent information in the application. So we have to learn how to create more than one tables. And once we create more than one tables, there will definitely be some relationship amongst them. So in a database at Georgian College, I won't keep information about the BMO bank. Doesn't make sense, right? But I'll keep information about all entities that exist in Georgian College and that are important to Georgian College. So that's what it will be. So your first job, though this course is not about designing it, but as I do it, as I move on to do multiple tables in a database, we'll talk about second normal form and third normal form. There are more. There is a fourth normal form, a fifth normal form, and a BCNF, Boy-Scott normal form. And these are design principles. What must you keep in mind when you design tables in a relational database? And they're important. They're like rules, right? So they're called design principles, but they're more of rules. So every table must be in the first normal form. We've already learned that. We know that, right? So we'll keep that. And then as we move on, we will learn what is the second and the third normal form, and how do we convert tables that are not in these forms to these forms. You'll say, why are the rules created? The rules have been created so that the design of your tables is long-lived. When I say long-lived, I say you just can't start, oh, this is what they want, I'll create a table, let's go ahead. In a week's time, you realize, oh, that was not the right one, I need to add a field to it. Another week, you realize, oh, that's not the correct data type, I should have used this. And that cannot happen. Remember, you're working with a live database, it's live, and you can't stop and start and stop and start and say, oh, changes have to be made, changes have to be made. Cannot be done. So the design process is very important and has to be correctly done, so that in the long run, the maintenance of the tables is easier and is not time consuming or money consuming. So cost wise also you have to think about it. So these are designing principles. What should the table form be? What is the minimum? 1F, but not the best. What will 2NF do in it? What will 3NF give me? What will 4, 5, and so on? All these normal forms. What will it give me when I create tables in a relational database? So you will learn them as you go. But again, since this is not a designer course, but I still need it in the sense that when you're programming, you should be able to argue about why am I keeping these fields in this table? Or why shouldn't I keep a particular field in this table, right? So as we go on, we will learn about those principles because they are important. So what I'm going to do today, so starting today, we will work on multiple tables in a database. So more than one tables in a database. So you will find that I've given you 4 files. There is a My Contacts Jobs, there's a My Contacts Job 2, and then there is a beer script and a sports script. So we'll start with the My Contacts Job today, and slowly and steadily, I will introduce you how to deal with multiple tables in a database. You still require to know your selects and updates and deletes and everything. But of course, you need to learn how to also do a join of 2 tables. You'll say, why will I need join? Think about it. All your information is in one table called student. All my information is another table called teacher. Now, if I want to have a table which says which courses does Anju teach, I mean, which student is under Anju, or what are the student numbers that I have Anju as a teacher, I have to start saying, oh, I pick up my name from here, I pick up your student ID, I look in a third table to see, do you see that combination of my name and your student number, and then the subject, and say, oh, there, Anju does teach that student, right? Which program are you in and which program do I teach in? Again, that information can be got from 2 tables and done. You have to remember something. You cannot duplicate or replicate information in a database over the tables. It's a big no-no. If required, yes, but otherwise duplicating data or duplicating means keeping it at more than one places, is a big no-no. Why? Because if a change has to be made at one place, for whatever reason, suppose now I change my department from computer studies and I move into nursing for whatever reason. Now this change should only be done at a place because my information should be only at a place. But if I haven't created my tables properly, maybe this information is also in a table which is saying Anju belongs to nursing and is teaching COPA course whatever. Like that would be disastrous because now I have to see where all do I exist and I have to change everything. So duplication is never a good principle at all, not even in programming. I'm not talking about tables, not even in programming. You write methods to do a job, right? You don't copy and paste that code wherever you need it. You write methods or you write functions so that each job is done by a method or a function, and every time you need it, you invoke it. Now, if changes are required, you will only go to that method and make changes to that method. So copying and pasting is not difficult. It's as easy as Control-C, Control-V. But maintaining the integrity of the data, integrity means accuracy of the data, whether it's correct or whether it's incorrect, depends upon duplication. So if you forget even a place where you haven't made a change, of course, it will create havoc, right? So therefore, the rule is keep information at one place or in one table. And if you need it somewhere else, just call that table and say, can you give me that information? And this is where you will need to join your tables. Okay. So starting today for the next 3 or maybe 4 weeks, we will be working on joins and subqueries. So I'll start slow today. I've taken up an example. I don't know from where, I can't even remember now. We will critique the tables in there. We'll see what can be improved or not improved. And then we will start to look at something that is available in MySQL, like verbs like union. If you want to pick up something from a table and and from another table and make a list, it's called union. Unfortunately, not everything is available in MySQL. Intersect, minus, these are not available, but we can do it by our own code, and that's what we will do, right? So the first example that I'm going to pick up is the jobs one. So you can open that up too, and you will find it in your zipped file. There's just one comment missing there, and when I come to it, I'll let you know, okay? So I'll pick up the same, and it's called oh, there it is, weeks 9 to 13. I kept them separately. It's called My Contacts Jobs _BB for Blackboard, right? That's the first one I'm picking up without the 2. And I'm going to save it so that I can find it later where I need it. And of course, you save it wherever you save your work. So today is Thursday, and I'll save it under week 9. Of course, when I finish a particular script. I put it on Blackboard always for your reference if you've noticed. If not, that's perfectly fine. That's information for you. And we'll save it. Okay, so let's critique the tables, or let's look at what it is first, and then we will start writing code to join tables or to work with multiple tables. So here is a database that basically contains information about some people, right, which I'm calling contacts. So some individuals, the job they're working on. So where are they working? The jobs they desire. So they're working somewhere, but they may like to be something else, not necessarily or necessarily. So people are looking for jobs. So that's a job desired. And then a table that keeps all the listings of the job that are out there in the market. So if a contact comes to me, if I'm maintaining this database, a contact comes to me and says, you know what, I'm looking for a job to be a DBA. Do you have it in your database? Do you know if they are available? The person will say, okay, I'll go to my job listings table. I'll look up if there is a DBA title there. And if it is, here it is, where it is, and there you can apply to it. But before that person can ask me questions, I'm going to keep all my contacts in a table, because I need to maintain a database. So you're my client, so all my clients go into the my contacts table, where I keep information about all my contacts. I could keep more, but I have restricted myself for what I need for this application. So I need your name, I need your phone number, your email, basically maybe, you know, where do you live? Because sometimes you have to say, oh, I live in Barrie, I don't want to relocate to Toronto to do a job. So that will help me to tell you, are there any jobs in Barrie, for example. So we'll look at these tables one by one and then critique them in the sense, can we improve them? Is there anything missing? And then we will try to draw an ERD, an entity relationship diagram for these tables. As the name suggests, it's telling you what are the relationship amongst these entities. Entities means what? That person, not that person, it could be the thing. I don't want to call it a thing, therefore we call it the entity, whose information will be present in a table. So a table will represent a entity. So for Georgian College, student would be an entity, and there will be a table for students. Professors would be an entity, and there will be a table for professors, right? And so on and so forth, right? So these are called entities. These are pieces of data, or these are pieces of the things that you would like to keep information on. So I'm going to work with 4 tables together here. I'm going to work with 4 tables together here. And then I'll show you how to create an ERD using the workbench. You can use the workbench. There are more softwares out there. You can use whatever you like, because it will be a requirement when you do an assignment that give me the ERD. I'll do a little cheating when it comes to it, because my script is already ready, and then I'll draw the ERD. But definitely the ERD is drawn before the script is written. So when the developers sit down and decide, okay, here is what my client wants, these are the interest, entities of interest, here are the fields I must put in each table, this is how they are connected, and they'll draw the ERD and then give it to the programmer, and the programmer says, oh, there's the ERD, that's everything information I need, and then he can start, or she can start to code. So you start with an ERD and then you create the tables and the script. I'm just doing the opposite way just because it's easier, right? But in the real world, ERDs are drawn first, and then the script is written to create the tables and so on. So we'll learn how to draw ERDs, or the workbench calls them ERR, extended relationship something. So extended entity relationship. So it calls it EER instead of ERDs. But if you hear the term, all it means is a diagram that is showing you the relationship between different entities in the table. Okay, so we'll learn to do that also. So today the aim is to finish this script off, but while I'm finishing it, kind of giving you the background of what will follow in the rest of the weeks. So please get it right. If there is anything you don't understand while I do it, stop and ask, right? So this is your basic lesson for joins and subqueries. Once you have it under your belt, it will be easy to go on to the next week. So we will keep doing and practicing, like we've been practicing selects and updates and deletes. We'll keep practicing that. And while I do it, I'll also introduce you to the second and the third normal forms, which I don't want to do separately because it kind of doesn't make a lot of sense. When you see an example, it makes more sense. Okay, so let's critique this database that I've created. If there is anything that you think can be improved, sure, let me know and I'll improve it right away. And then once we have everything running, then we'll start writing our joins and our subqueries. Okay, so let's start there. So the first one, the purpose simply says to create a database and some tables therein, populate them with data and extract information from the tables, right? So using joins and subqueries. So that's what your aim is. Okay, so the first three statements, basically setting up your environment, not a big deal. We've done them before, but something new that you're seeing today is line number 10, which says, what is the default storage engine that my script is going to use? I've mentioned this before, but I'll refresh your memories that there are various storage engines that work differently in a relational database. You'll say, what are storage engines? Storage engines are those engines behind the database that make your queries or your updates or your deletes work, right? So they do the job of how will I optimize the query that has been given to me? How will I optimize it? So maybe a few years back, we had to think a lot of, oh, am I writing the most efficient code? But engines are now optimized, so are compilers, right? In languages also, so that they do your work in the least amount of time. But you just can't assume, oh, let them do the work and I will not write efficient code. The job of a programmer still remains the same. Write good, efficient code that is done in minimum time. So if you kind of Google the various storage engines that are available for MySQL, you will notice that there are a few. And I would highly recommend giving them a reading, quick reading. So here are what are supported in MySQL. You can go to the reference manual and it says 15 alternative storage engines. So there are 15 storage engines that are available in MySQL. Of them, MyISAM and InnoDB, the one that I'm using, are the most common ones. And there are pros and cons of every engine. So for example, InnoDB will support foreign key constraints, something we will be doing today, which ISAM doesn't do in self-referencing keys. In a storage engine, if a particular person is writing something to a data, the whole table is locked. No other user can even extract information from it. But another storage engine will say, why should I lock the whole table? If a particular record is being added, I'll just lock that particular row which is being added, and the rest is open to whoever else wants to use it. So locking of rows, locking of tables, all this is a property of storage engines. So again, the two common ones are ISAM and InnoDB, but you do notice there are a few here. I haven't used all of them. I have in my career either used MyISAM or InnoDB. I've read about others, but I forget it, right? So what I would recommend to you definitely is to give this a quick reading. Maybe will take you half hour or so if you're interested, of course, but definitely pay attention to or lay emphasis on MyISAM and InnoDB. So I have chosen the storage engine in my code to be InnoDB for a particular reason, because I'm going to use foreign keys today, foreign key constraints or rules today, which I'll explain when I come to it, right? Now you can put it as a set statement like I have done at the top, I mean, wherever before you use it, or the option is for each table, you can set a different default engine. So for this table, the engine is ISAM. For the second table, it is InnoDB. For the third one, it's memory. Depends upon what are you doing with that table, right? So the table kind of determines what am I doing with that table, and you decide what storage engine you will use. In that case, I'll show you how you do it. So again, I do not know what's on the server. I have no idea. So when I write my script, I make sure that I write everything. So again, we don't need if we don't do updates, we don't need the updates is equal to 0. We won't be doing any updates today. If there is nothing that has to be done with not null or null, if I can remember, we don't need the set one, but definitely we are not going to update data today. So you can remove this one if you like, right? Which brings me to this point, and I must point it out, that when you give me your assignments, please only do what I've asked for. If I've said describe the table, I'm not looking for show tables and show the structure of the table. I'm not looking for it. Don't copy and paste my code without thinking what is being asked. I ask for 4 outputs and I get 14 outputs. Now, it's my job to kind of go through the outputs to see which is the one I am interested in. And I'm not doing it. For me, that is redundant code. And you're wasting my time, right? So, for example, I'm marking the assignment 4, the alter one. I only asked for 4 outputs. Describe the auto table, select the contents. Describe the table auto, select the contents. 4 outputs. I think hardly half the class has followed instructions. What you guys do is you just copy my code. If I have show tables or whatever, you just put it there. It creates output for me, and then I have to kind of clean up the script before I really run it as I want. Like I've had it now, right? You've done half the semester. Scripts are not running again. 3 or 4 scripts I have not run till almost half the marking. Again, you're expecting me to see what's going wrong and doing it. And I opened up my assignment. Unfortunately, that line was not mentioned. I will only mark till where I can see. But I mean, it's something that you should understand. If a script runs, I mark it. If a script doesn't run and I don't see output, I'm not marking it. Right? So I think I have to put my foot down. I've been kind of, some of you know that I've been kind of saying, okay, I'll let go this time. Please be careful in future. But I again find it. So I've kind of given up. Things that should take me maybe 6 hours to mark, take me 10 hours to mark, because I have to clean up code to do it. And some are so neat and clean. It's like smooth. I run it, I see the output, I browse through them, takes me 2 minutes, done. And that's what is required, right? That's how you should code. So you don't have to rely on me. You have Workbench. You write your code, you run it, you see whether the output is right or wrong, and you know that this is what I have to give as a submission. But no, you don't care. You say, here, Anju, you take it, you figure out what I'm trying to do. That's not fair. Like, you can do that to your employer, can you? This is all I can do. The rest is up to you. You'll be out of your job in a minute. Treat me the same way. I've asked for something, give it to me. You can't do it, that's okay. Don't do it. But don't give me crap for it, which I have to, check or uncomment or comment or do whatever to make your script run. It's kind of becoming quite irritating. Like, you've done 3 assignments, you've done a midterm, and you're still not understanding the instructions. So it's not all of you. As I said, some are beautiful. Like, it takes me 2 minutes to mark them. But still, it's still out there. So I'm not sure if these are students who don't attend class at all, so they don't know what's going on, or these are students who are just careless. So please keep in mind, when you give me something, it should run. Whether the answers are right or wrong is a different thing, but it should run. It shouldn't stop anywhere. And if they are wrong, you can even check them. Like, you have a tool with you where you can see your answers. You have your data, you have your answer. All you have to do is double check. But maybe you don't have time. Anyway, can do a lot about it. This point onwards, I'm just going to be strict. If you've done it, done it. If you haven't done it, you all know. If I can't see an answer, I can't see an answer. So this set default storage engine is saying that for all the tables, storage engine is related to tables. For all the tables in my script, I'm going to use this engine called InnoDB. Now, if you wanted to be particular about different tables, suppose my contacts was using a different engine, all you have to do is you can write it here. You've seen this before. When I write the show create table command, you will see that there is an engine equal to whatever. So by default on my machine, it is InnoDB, but I can't assume it, right? I can't assume what's on your machine or what's on the server. So when you write a script, please ensure that you have given a complete environment, what you want to work in for your script. So you can do it here and you can enter it here. And it can be different for every table. Because remember, the storage engine, they're storing how the data is being stored in a particular table depends upon what are you going to do with that table, right? So when I say what are you going to do, that means are you going to What kind of extraction of data or updates or deletes will you do? And that's what determines it. So please read a little about it if you have time, or if you're interested to see what the storage engines are. And as I said, the two most common ones are the InnoDB and the MyISAM ones. Okay, so let's look at one table at a time. So I've given you a kind of an idea of what it is. It's basically a database that is keeping information about contacts and jobs and so on. Okay, that's what it is doing. So let's look at the tables first. So again, the usual drop, create, use. The drop table, which is useless for us because our database is dropped. And here we start with the create table. This is my first table. I'm calling this table my contacts, and these are my clients, right? So these are my clients, which is basically whose information I'm going to keep, people who are coming to me to look for jobs, right? So I'm basically their hunter in a sense. Okay, so let's see what information would you like to keep about a contact in your database. Of course, the first name, last name, phone, email are common. Like how will I contact them when the time comes? The contact ID is the primary key of this table. And since I can't think of anything else of how will I recognize a contact, I made it an auto increment key. So when you add your first record, it has a value of 1, 2, 3, and so on and so forth. So as I said, sometimes you can find a field that can act as a primary key. The easy way out, or some programmers prefer it actually, the easy way out is to create a auto increment primary key. So I've made it an integer. I could have gone small int also, but assuming it will be a huge database. Also, something you have to keep in mind, I give you data which is small because we are working in an educational environment. I can give you data which has thousands of records. All I have to do is go to the web and copy. But then how will you check whether your answers are right? So the idea of giving small databases is manageable, right? So I give you a small database, a small number of records in a table, so that when you write a query, you can see if your answers are correct. I haven't gone more than 15 or 20, I think, in any table. But that doesn't mean that that's the only data that is available. For example, in your alter table structure, I've given you 3 records, one for Porsche, one for Jaguar, and one for something else, I forget. And I said, update the records, update the VIN number. You can't update it on make. You're saying update the VIN where the make is Porsche. How can you do that? There will be many Porsches in the database. They all get the same VIN number, which is entirely incorrect because VIN numbers are unique. That was what it was. It is a unique number given to a car. So keep in mind, whenever you update data or delete data, the primary key is what you should use if appropriate. That must be your first choice. Of course, if I say update the data for name is equal to Anju, then it's something else. But if it says is update the data, you always update the data in a table on the primary key because the primary key is unique. It uniquely identifies your data, and that's what you want to do. Think of it. You're saying set the VIN where the make is Porsche. Now, all the cars with the same make will get the same VIN number. And just before that, you're saying alter my table, VIN is unique. You're contradicting your own state. So of course you won't get marks for update. It's a wrong update, absolutely a wrong update. Okay. So you have to think when you do an assignment, if I give you everything, like everything, do this, do this, do this, do this, draw the line on the right, draw the line on the left, give this attribute, then where lies your need to do the assignment? You're just doing, okay, 1, 1, 2, 3, 4, 5, 6, 7. When I say create a table and use fields of the best fit or appropriate types, it's your job to see what the appropriate types is. Something which is a model year, there is a type called year. Why would you use an int for it? Years are years, and their values are defined, cannot be negative. They have a certain value. They're already defined as a type. Why would you use an int for something where you're saving the year, model year of a car? It's not the appropriate type. Similarly for price, why would you use an int? It's a decimal, right? So appropriate types, that's the first lesson you learned in week number 1, to use the correct best fit types. And you cannot forget it as you do your assignments. That rule still remains, has to remain in your head, and you have to follow it every time you do it. Asked or not asked, doesn't matter. But anyway, so keep that in mind when you work. You can't forget what you've learned as you move forward. You accumulate your knowledge as you move forward. You add to it. I mean, why will you not look at the fields and say, oh, what do I need for it? So I have gone unsigned for auto increment, though if I don't do anything, auto increment automatically starts with 1, 1, 2, 3, 4. But what if somebody writes an alter statement and changes it to say minus 300 or whatever, or to 0 or to something else? I don't know who will change my script. I mean, it's not my script. I'm working in an organization. There is many people are working in it. So I've taken care that my contact ID must be a positive number. Not required, but a good point, right? Then comes last name. I've gone with 30 and 20. You can go 40 or 50, but don't go 100 and 120. That's too much. I've said that these fields will be not null. Primary key by default is not null. You should not write not null with it. It's redundant. Don't write redundant code. Then comes the phone number. Now the phone number I've taken not to be an integer and to be a character. If you think of phone numbers, it automatically says, oh, it's an integer. It is not. Phone numbers are sometimes also written with brackets. The area code is written in brackets, and there are dashes between the 3 parts. Like in Canada itself, we have a 10-digit number, but if you start putting brackets and dashes, that's not what it remains. So I won't take it to be an integer because it makes no sense. I'm not going to do any math with it, ever. Will you do any math with a phone number? No. Do you compare phone numbers? No. But yes, you may be interested in people living in Barrie, so you can extract the first 3 digits, the first 3 characters and say, oh, do you live in Barrie? Do you live in Toronto? Do you live in wherever and wherever and so on? So I chose it to be character, not even varchar, because the phone number is of a fixed size. The second important thing, very important thing that you have to understand as programmers is the rule of GIGO. Garbage in, garbage out, right? So what you store in a database, if it is not correct, not validated, the data integrity is not maintained, output is useless. So assuming that on the front end, when you pick up your data, that is where the data is validated. So in the front end, the data is validated. When names are taken, regular expressions have been used to check that there are proper names. They don't have semicolons and question marks and so on in them. The phone number, usually the field of phone number will automatically have those brackets and dashes. All you do is fill it in. So the front end, the job of the front end programmer is to ensure that the data taken is correct. Then it is passed on to the storage through the middle layer, the programs that you write, that data is passed on to the data storage to kind of say, okay, now you can store this data. We follow the MVC model when we are creating an application. So what does MVC stand for? M for the model, V for the view, and C for the control, right? So the view is at the front end, the model is the programs you are writing, and basically the C is, the C is the control that you are writing, and the model is the data storage, right? So we follow, almost everywhere we follow, in all programming, we follow the MVC model. M for model, which is how will I store my data. V for the view, what will be my front end. And C for the control, that is basically the person or the logic or the programs sitting between the front end and the back end. So back end is modeling, front end is view, and the control is C. So definitely data should be validated when it is collected at the front end, and then the control passes this validated data to be put in the model. Your model could be files, it could be databases, it could be anything. How you're storing your data is entirely different, but the MVC model needs to be followed every time you write an application. Okay, so, or you'll say, oh, I have a data already, all I'm doing is I'm just typing it in. Then again, it's your job, whoever is typing in data in a database, in a table, inserting it. If it's all manual, usually now nothing is manual. Data from the front end is saved in a CSV, a comma separated file, and you can write code to convert that CSV and put your data into tables. Like all this conversion is now possible from one type of data to another. They're called CSV data, comma separated, easiest one, and the most used one out there, right? So data is collected, put in a CSV file, which is a comma separated file, and then the data is transferred to a database using, of course, using a program. Like I can show it to you how to convert data in a text file onto a table using Java, for example. Okay, it is all done. So manually, it's not more automated now, definitely, than manual. But still, you have to keep in mind that data that should be entered or that is entered in a database should be correct, right? So I have stuck to character 13, and it is a high recommendation that fields like phone number, student ID, employee ID should all be characters, even though they look like numbers, but we never do any math with them. Okay, then why do we use this contact ID to be an int? Because there is no other option with auto increment. If there was, I would use it. But the only option with auto increment is that the field must be an int. But otherwise, not necessarily that if a field data looks like an integer, you make it an integer. Keep that in mind. So my phone number is character 13, not even varchar, because every phone is occurring in this format. Right, so you have your phone. This is data not from Canada, it is US. So you will notice that the zip is also only character 5. But even in Canada, we have 9-digit numbers. The email, I've gone with varchar 50. I think it's more than enough. I don't think people have more than 50 emails. You can go less if you like. Again, the email is validated at the front end using regular expressions. Have you come across regular expressions in any other programming language yet? Maybe in Java. What is a regular expression? A regular expression is an expression, like it has characters that will double check that what you're inputting is right. So emails should have an at, should have a dot, should not have more than 2 ats. And again, any special characters or whatever cannot have blanks and so on. You can create a regular expression for it. And a regular expression looks like something like this, not necessarily, but this is an easy one. So suppose for a phone number, all you want to allow is digits, and that's what you want to allow. This is a regular expression for a phone number, for example, right? So what does it say? I will allow you to enter digits in all these positions, and a digit is from 0 to 9, right? So a regular expression is formed, and you don't even have to do a manual check. When the data is being collected at the front end, it is compared against a regular expression, and it says, oh, okay, that's right. Otherwise, it gives something to the user saying that's an invalid phone number. So I'm assuming again that the email that is given to me when it comes to the modeling, when it is being stored, is in the right format. So if you look up, you Google regular expressions for email, you will get loads of them, right? And then you can kind of try to understand them. But this is a very easy example. Sometimes you will also see instead of a D, a 9 is being used. 9 means the same thing. 9 means it's a number. It's a digit. That's another regular expression. Depends on which language you're using. So every language has a set of characters that you can use in a regular expression. So if I wanted alphabets, letters, like any letter, then I will write something like this. And any letter from A to Z can be written like this. So you're saying, oh, anything that is from A to Z. There is something else which says nothing, except anything. So except a letter, give me anything. And then you can use square brackets and repeat it any number of times. Right? So there are different characters that are available to use in regular expressions. And a regular expression is like a template. So you give the input, it is compared against the regular expression, it fits it, data is correct, it doesn't fit it, data is wrong. So for an email, if you Google it and you say, show me regular expressions for email, because that's not the easiest one, you will notice that what you're allowed 1 @ for sure. Then there is a dot that is allowed because you say .ca, .com, .in, whatever, and the rest can be letters and digits and so on, right? So that is what a regular expression is. I don't know, hopefully you will learn it somewhere as you move on in your Java courses. I think we do it in the second one, which you guys are doing now, right? You're semester 2 students. But I don't know, it really depends on whoever is teaching it, right? But that's what a regular expression is. So assuming that data has been validated and all data that is being stored is correct, I'm saying that the email is 50 characters and it is not null. Gender is either M for male or F for female, and I've given it a character 1. Now, from what we've learned, I could improve this definition. Instead of saying character 1, what can I go? I can use my enumerated data type. I can use M for males and F for females. And automatically small and positive doesn't matter. You haven't made it case sensitive, but if you want to, that's different. I haven't set that my sensitivity is case sensitivity, which you can again do by a set statement. Set collapse sequence to something will make it case sensitive. So I only write M and F, automatically small m and small f are also allowed. So definitely instead of character 1, which will allow any character in gender, even a question mark, you know what I mean, a comma, any character, I've restricted it to M and F. So that change would be a good change, right? An enumerated type would be a good change. Then comes birthday. You'll say, what's the use of keeping birthday for a contact? He's looking for a job. Many jobs are age dependent. You should be this much of age, or your age should not be more than 50 or stuff like that. So if you keep the birthday and you know today's date, which you can always get, and you subtract the 2, you can find out the age of the person. Then you say, why didn't I just keep the age? Because asking the age of the person is more difficult than asking the date. Why? With a date, you can show the date picker, right? You can show the date picker, the user picks up the date, no mistakes will be made. With an age, the person is saying, oh, do I give it 25 years, 4 months, or whatever? But again, you can make a list, you can do a drop down, and the user can choose an age. It will not be less than 0, and definitely we are assuming it will not be more than 200. So a drop down can also come. But what you're trying to do is you're trying to make input collection as foolproof as possible so that the data that is saved is correct. And that is very important because we don't want to have garbage as output if your input is garbage. So I went with birthday, just thinking, oh, it's much easier to take it as input. You use this is a date picker. This is what a date picker is called. You can show a date picker in your front ends. You've done HTML, right? You guys are doing web or front end also. So in the front end, I'm sure there is a way to show this date picker where the user can choose a date and never go wrong. Believe it or not, a couple of decades back, we had to enter it ourselves when there were no date pickers. All these GUI tools or controls haven't been there forever. So then there was always confusion, but there were instructions, mm/dd/yy. But a user could give anything in mmdd and yy. You know what I mean? Like I could give 21 in the year, and it would, I mean, it's not wrong. So now that you have a date picker, you can go wrong, right? So that, of course, you should check that your birthday is less than today's date. That's something you can check. But date pickers are easy now to pick up a date. So things have improved. GUI has taken a tremendous load off programmers. Otherwise, you had to code everything and check or validate your input yourself. Now with tools like this, GUI tools like this, you're restricting drop-down boxes, right? Radio buttons, check boxes, date pickers. Now you're kind of saying, oh, you can only choose one of these. So you're kind of saying, I'll validate my data right at the front end. And that's important. You should validate your data at the front end before the controller passes it to the back end. Okay. So the birthday was taken to find the age of the person. Why? Because in some jobs, age matters, right? Age is taken into consideration. Some not, some yes. So birthday is again another important field. And the zip, Canadian zips are definitely not character 5. They are more. We are 6. But this is again, this data is all American, so it's a zip file. The use of zip. Why am I saying where do you live? Because maybe you're looking for jobs only in Barrie. You don't want to relocate. Or you're looking for jobs in Toronto. You want to relocate to Toronto. Or it really doesn't matter to you. So I'll keep the zip for the person to find out. Instead of keeping the whole address. I'm not interested in your address. You know what I mean? Like, it's okay. What will I do with your address? It doesn't make any sense for me. Yes, your phone number does, because if I have to contact you, I can call you. Some people don't like giving their phone number, so I didn't say not null there. Or I can contact you through your email. So I need some contact information, and mail and phone are okay. Gender, jobs, again, should be a male, can be a female. Both males and female can apply. Usually it's always both can apply, but gender is okay. birthday for age, first name and last name, of course, for who you are, and zip to tell me where you live. So that if you are looking for jobs specifically in certain areas and they are in the job listings, I only give you that information if it matches your zip, for example, right? So that's the use of zip. So these are the fields that I think are enough for a job hunter when he or she is keeping information about their clients. I can't think of any other field, but if you can, we can always add it to here. And we can say, oh yeah, that makes sense to add it to the table. What follows are insert statements in which data is inserted. So again, I didn't insert it. I copied it from whatever my source was. I double checked that everything was okay and ran the script and it will run. So that's my table number 1, something that a job hunter will, of course, keep for his clients. Let's look at the second table. The second table is giving information about my contacts who already are doing the job. So it's not that a job hunter only has information about people who have no jobs. I am in a job, but I want to look for a part-time job maybe. Or I want to look for some other job. I'm not happy with what I'm doing. I would like to look for some other. Or I just want to move to the industry now from education field. So here is information about the contacts if they're working. So if you have a job, you will be in this table. Your contact ID will be in this table, your title, your salary, and your start date. When did you start at that place? The start date is not very important. I mean, I don't care when you started in your current job, but it was a field there and I left it there because it was a date type and I thought, well, it's a date. No, it's no big deal. If we have to do something, at least we'll know how to work with it. Now, what is this contact ID, which I say is an int and is an unsigned int and is a primary key? This is the most important thing to now understand of how you are linking this table to the contacts table. Now, keep in mind, I am a job hunter, right? I have some clients. I would like to keep information only about my clients in my database. So, people who are working, I'm not interested in people who are not in my list of contacts. People who are working and are in my contacts table, I want to keep information about them. So what is very important is lines number 68 to 70. You could have called this anything you like. It doesn't have to be called contact ID. You could have called it, I don't know, anything. The contact ID just seems to be easy. Look at lines number 68 to 70, which are now relating this table, job current, to the my contacts table. What does it say? It is saying that now 68 is just giving the name. It's saying I'm creating a rule here. Constraint means rule. I'm creating a rule. You'll say, why am I giving a rule a name? Because if you need to change it, alter it afterwards, you know the name. That's why names are important, right? Not necessarily for our course because we are not going to do any programming, but as you move forward in SQL, you will require to give constraints some names so that you can change them when required. And the convention is you give the name of the table and the field on which your rule is dependent. So my rule is dependent on the contact ID field in the table my contacts. So since there is a dependency there, I name the table, I name the field on which my rule is dependent, and FK1 just stands for foreign key 1. Okay, it helps me. If I look at it, I can make an educated guess that this restriction or this rule is on contact ID of the table my contacts. It gives me that idea of which table is involved. But what is the rule? Here is the rule. The rule says that this contact ID is a foreign key. Now, what is a foreign key? You know what a primary key is. Now let's look at a new aspect of databases, which is called a foreign key. A foreign key is a field whose values are drawn from another table, another column in another table. So this contact ID should be a value present in the my contacts table. Otherwise, it's incorrect. I'm only keeping information about my contacts in my database. This person has a job. This person should be in my contacts table. So the foreign key says that the contact, who is the foreign key in this table? There could be more than one foreign key. Not like primary base where it can only be one. It says this contact ID is a foreign key. And a foreign key is a field that draws its value. Its values can come only from another column in another table. And most of the times, 99% of the times, it will be a primary key in the other table. Contact ID in my contacts is a primary key. Otherwise, you cannot add this contact to your job current table. Make sense? Why would a job hunter keep information about ABC if ABC is not even in the table, if it's not his client? It's like saying, why would a doctor keep information about a patient if he's not his patient? Same kind of concept, right? And then you're saying that this foreign key is referencing or references the value of contact ID from the table My Contacts. That's exactly what I'm saying, right? A foreign key is a field that draws its value from another column of another table. So what is that column? What is that table? Comes in the references. So contact ID of this table, which you could have called anything, contact ID 2, contact ID job, whatever you like. It's not necessary to give it the same name. Same name doesn't mean there is a relationship. The relationship comes from here. It says the contact ID is a foreign key and its values have to come from the column called contact ID in the My Contacts table. Make sense? Here is how you've made a relationship between the two tables, which means that in the job current table, I cannot have something like 19. Why? Because 19 is not a valid contact ID in the other table. So it should run till here. Let's try to run it till here. This is my second table. So some people don't have a job. I kind of gave it in sequence, but you don't have to. So if I run this script only till here, it doesn't like the DB. It was doing the same thing yesterday also. I'm going to call it DB jobs 2 or 1 or whatever. Yesterday also it wasn't able to delete my database by that name. I don't know why. It must be corrupted or something and therefore it can't do it. So I'm just changing my name. You may not have to. But when I did it yesterday, I was getting the same problem. Sometimes it tries to delete a database and it cannot. Still an error. Duplicate entry 1 for primary key in which table?
That one that you
Technical writer?
No, the one you changed to 19.
Oh, did I? Did I change it to 19? Didn't change it back?
You changed it to 1.
Oh, I changed it to 1. Yeah, and that makes sense. It says 1 is duplicate. It is, right? It is a primary key cannot be duplicate. I should have changed it back to 9. Thank you. Definitely, the error is there. That means I've made an error because the contact ID was unique, has to be unique. So you're saying, what if a person has more than one jobs? Unfortunately, here I can't put that information because my primary key is the contact ID. So I'm assuming, it's not a good assumption. Of course, I can do a better design. I'm not saying I can't do it. This design doesn't allow me to do it. I can make a better design for it. Okay, that's how you will learn how to make designs. Necessarily not maybe because it's not a designing course, but I'll still give you hints as I go on. So in this table, I can only keep information about a job for a client, which is not necessarily true. Some people work more than one jobs. So now let's try with the 9. And if I try it with the 9, everything works and it looks fine. We already saw that 1 gave me an error because 1 was a duplicate key, but 19 will also give me an error, but the error will be different. The error will be, it will say that a child row, I cannot add or update a foreign key. If you kind of look at the error, it gives you an idea. It says cannot add or update a child row, a foreign key constant, and it is telling you the name of the constant is being violated. Of course, you violated the constant. You said that the value of contact ID must come from the contact ID in the other table. Is there a 19 in my contacts table? There is no 19 in your my contacts table. You say, how will I know? Because there are only 10 records, right? So it was an auto increment field, but even if it is auto increment, it starts with 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 only from 44 to 53. So definitely it's not there. So that's what a foreign key is, right? That's what a foreign key is. A foreign key constraint says that the value of this field must be a value already present in my contacts table. And that's a valid rule for us. Why would I keep information of somebody who's not my client, right? Now let me try this. I could be wrong, but just for the heck of it, I'm going to change my storage engine to ISAM. I'm not sure about all properties of ISAM, okay? I'm going to change it to ISAM, and I'm going to try this 19 again. Oh, it says unknown storage. Oh, why? Oh, I forgot to put it in quotes. That's why. I think it's called ISAM. I'm not mistaken. Is it ISAM? My ISAM. Okay, you're right. It's not ISAM, it's my ISAM. You're absolutely right. I'm trying to see if my ISAM is okay. I mean, you don't have to give it all in caps. My caps is on. Is my ISAM, will it support this foreign key? I think it supports foreign key, but it doesn't support self-referential foreign keys. And we'll talk about self-referential foreign keys maybe another week. Actually, see, it doesn't, it's fine. It allowed me to put 19 there, so it doesn't support foreign keys. And that's why I don't want to use it. I mean, what's the sense? I've created a rule, the rule is not being implemented. So therefore, you do not use my ISAM as your storage engine. It doesn't work. I mean, it is working without error, and that's not what I want. So I'll go back to my InnoDB. So there it is. Oh, it didn't have to put it in quotes. It was just not right. Okay, right? So if I give 19 here, I'll save this. If I give 19 here, you did see that I was getting an error. So that's one example of why did I use InnoDB as my storage engine over my ISAM. Makes sense? Right? So every storage engine will have its own properties, and depending upon what you want in your application, you will choose the right storage engine. And it's not necessary that you use the right one in the whole script. Every table can use a different storage engine. Maybe in a particular table, you want to lock the table when anybody is writing on it. The whole table should be locked. You can use the correct one, the one that does it. I think InnoDB, my ISAM locks the whole table. You only want to lock the row. Locking means nobody else can access it. No other user can access it. You want to only log the row in which you're writing or updating, which makes sense. The rest of the data must be available, right? Then you use InnoDB again. So that's why I said give it a read. Not everything may make sense, but some things will make sense, right? So again, not everything makes sense when I read them, but I still can infer something from it. So I just showed you an example. So 9 should work, okay? 19 will not work. You can try. Okay, now this 1, 2, 3, 4, 5, 6, 7, 8, 9, it was just me. I was putting in data here. I mean, I just gave them those keys because, I mean, just sequence, right? Humans just think sequence. You can enter for 7 and 10, and you can say, oh, 7 is unemployed with null and null, and 10 is a student with null and null. That's their titles, but it's not necessary. If the record is not present, these guys just don't have a job, is all it means, right? So if I'm saying who has a job, who doesn't have a job, I can come to the job current table and say, oh, let's see who doesn't have a job. How will I know who doesn't have a job? I'll pick up this contact ID. I will go and look in the my contacts table, and I'll say you are in my contacts, but you're not here. So you don't have a job. You are in my contacts table and you are here too. You have a job. And that's how you will start joining the tables. That's why you will need to join tables to answer your queries. So some queries may come from a single table, hardly, but some queries will come from more than 2 or more than 2 tables. Let's look at the third table now. The third table the job hunter is maintaining is a job desired table. He says, okay, I'm going to keep a list or a table of all my clients who are interested in finding a job. Now, people may already have a job, but desire another one, or people may not have a job and definitely they are looking for a job. So you will notice again, let's look at the properties. Again, it has a field called contact ID. You could have called it anything else, contact ID 2 or 3. It is an int unsigned primary key. Every table that I'm creating is in the first normal form. That's the minimum. Okay. Actually, all these tables are also in the second normal form because second normal form depends upon a composite key. The key has to be composite, more than one field. But all my keys are single fields. They're only one field, one column. So they're automatically also in second normal form. When we come to an example which does not have a single key, then we'll talk about second normal form. Okay. So this contact ID says, oh, this is my contact ID. I'm looking for this title. So I want to be a computer programmer. I want to be a chef. I want to be a baker. So this is what I'm looking for. This is my desiring job. This is the low salary. This is the lowest I will go with. I don't want to go below this. But my expectation is salary high. This is what I'm expecting. So sometimes when you have no choice, right? There is an economy is not doing good, or the jobs that you're looking for are just not there in the market. You kind of say, okay, I'll take this for now. But your expectation, of course, is more. Okay, so job salary low says that's the minimum. I'm ready to go till there. Salary high says this is what I'm really looking for. Okay, again, are both fields necessary? No, the low is good enough. This is the low. I won't go below this. But high, the salary high was kept to say, oh, this is what I'm expecting. Okay. So worse come worse, if you can find something for salary high or more, then I'm ready to take this salary low. So that's what the salary low and high. And how many years of experience do I have? If I'm looking to be a baker, do I have 10 years of experience in it? If I'm looking to be a computer programmer, I have 15 years of experience in the field. So experience helps. Why? Because when the job hunter will look for this guy, he says, this is what you're desiring. Oh, it's in my job listings. But the listing says they need 10 or more experience years. So you can mix and match, right? So job desired table is again a small table which says, I'm looking for a job. This is the job I'm looking for. This is the title I'm looking for. This is the lowest I will take. These are my expectations and these are my years of experience. Now, years of experience is a tiny int, unsigned default 0, just because some people may have no experience, so default works well. Tiny int from 0 to 255. I don't think anybody will have more than those number of experience. So nothing smaller than tiny int, and unsigned because it has to be positive. Okay. So be again careful. If I've said I want a default value, you put a default value in your create table. If I haven't said it, I don't want to see it. I don't want to see it. That means you're not following my instructions. Maybe it's right for you. You think, oh, price is 0. The default 0 is good enough. But I didn't ask for it, which means you're not following instructions, which means I'm going to dock off marks. Right? If instructions are given, you follow them. You can't say to your client, oh, I don't like your idea. I'll just put my own in it. Unfortunately, no, the client will not allow it. And as an instructor, I'm not allowing it because I'm making an assignment that I want to be done by all my students symmetrically. Right? And that's what you do. I give a name of my field, like in the auto table, some names were bad, Mo for model, how much for price. I've given it for a reason. I want you to use them and then change them using the alter table statement. But no, some of you are smart. Oh, how much is not a good name? I'll call it price here itself. Mo is not a good name. I'll call it car model. Like the whole purpose of the alter is gone then. The aim was I give you bad names, bad types. And then you write alter statements to give good names and good types. Anyway, so it's nice that you have your own ideas, but in assignments, please restrict yourself because there is a reason why I'm doing it. Again, there is a rule here. Makes sense. There has to be a rule. If somebody is desiring a job, he's in my contacts list. So again, I'm saying the same thing. I've created another rule. Again, I'm telling the name of the table and the field on which the rule is dependent, and FK2 just because it's a different. So FK1, FK2 are just joined to say foreign key 1, foreign key 2, and so on. What is the rule? The rule says, looks the same, but it says the contact ID of this table must draw its value from the contact ID of the table my contacts. Make sense? So there is the rule. If you don't put that rule, then you're not making a good design. Why am I keeping that rule? Because why would I keep information about clients who are not my clients? So again, 7 is looking to be a computer programmer. 7 didn't have a job. So you see, he's saying I have 10 years experience. 80 is the minimum I'm ready to take, but I'm expecting 100. Okay. 8-1, I don't know what he is, but he also wants to be a computer programmer. 4-1 wants to be a sales manager. I don't know what it is. 10 was a student, didn't have a job, wants to be a baker, has 2 years of experience, maybe part-time experience or whatever. And then 9 wants to be a chef, and he has 20 years of experience, right? So there is the data, which some fields could be null or not null. All fields are not null. Title is null. So some guy may say, oh, I'm looking for any kind of job. Really doesn't matter. And my years of experience, it has to be an integer. If you don't give anything, you can put null here, or you can put null, you can put 0 here, or you can use the word default. Actually, you can also put null because null is allowed. Some people are not, they don't give a title. They'll say any job will do. I'm just looking for a job, doesn't matter. So for that, for those guys, maybe their salary low and salary high could be 0 too. I mean, he has no restriction at all. He's just looking for a job. Okay, so it could happen, and therefore I have not said not null in the title field. And that's fine. Some like students, they'll say, oh, I'll do any kind of job, doesn't matter. I just want to kind of, do it in my, so that I can take out money for my living or for my tuition. So they have no particular, in that case, you can leave the title as blank or you can put it as null. That means they have no preference, right? So that's another way of thinking what field should be null and what field cannot be null and so on. So title is not null because I thought, you know what? You could be looking for any job. For salary low and salary high, if you like, you can give a default of 0. For students, I'm just thinking from students' point of view. But again, some students are very particular. They want to do what they want to do, which is fine. The last table in my database is job listings. The job listings is an independent table. It doesn't relate to any of the other tables, to the contacts or job desired, job current. It's just a listing of jobs in the market, right? So it says I'm job listings. I have a job ID as my primary key. I have these titles are available. This is the salary they are giving, and this is where they are available. So here the zip says where is the job available, what is the salary it is offering, and what is the title of the job, right? Now title should usually be not null. I mean, every job posting does have a title. It's not that it won't have a title. So let's say this should be not null. The title should be not null. And it has a zip. Zip means where is it available? Again, this zip will come handy when my contacts are saying, oh, I want a job in Delhi. I want a job in Toronto. Now notice it has an auto increment primary key. And it's very common. As I said, some programmers just like the idea. They don't want to think about any other field that will act as a primary key. They want their table to be in the first normal form because that's the minimum rule. And here, what else would you make the primary key for a job listing table? Nothing much. You can think of anything, right? So I just made a job ID, which was auto increment. So every job is identified by a number. It's 1, 2, 3, 4, 5, 6, 7, 8, whatever. You can make it unsigned if I haven't. It is an auto increment primary key. So this table is not related to any of the tables, but this table is important in the database. Because if people are saying, these are my job desired, this is what I'm looking for, is there an option for me? You will need it. And then there are some values in the job desired. There is a job for a baker, a clown, a dog trainer, a hairdresser, a jeweler, a lawyer, mechanic, neurosurgeon, web designer, teacher, salesman, artist. So these jobs are available. Having said that, this script should now run and give you 4 tables. So try to run the script if you've understood the whole concept. So the first thing is to understand the whole concept, that why am I creating what I'm creating and what is a foreign key. So that's your table 1, all contacts in my database. That's your table 2, people who are currently working. That's your table 3, the jobs people are desiring. And that's your table 4, the jobs out in the market. Right? Now, so I've already created my script. So now I'm going to do a reverse thing, which should be done before. And you should learn how to do it too. Under database, you will find something called reverse engineer. So once you have run the script, your database is ready, your tables are ready, I'll do a reverse engineering. Therefore, it's called reverse because I'm going the opposite way. But it should be done before you create your script. And you will know why am I saying before. Go, is the connection right? Yes. Connected? Yes. Which table, which database are you interested in? So mine was called DB Jobs 1. This is the database I'm interested in. I'm going to create an ERD for my database, an entity relationship diagram. Okay. Go to next. It says, okay, I've retrieved it. It says you have 4 tables in that database. Yes, I do have 4 tables. Execute it and finish it. Notice what it has done. It has created an ERD, an entity relationship diagram for you. They're showing you one, it is showing you the table. So table my contacts. Now please understand, the yellow looks like the key. That's the primary key of your table. Right? The diagonals, the diamonds, some are blue, some are white. These are fields. Not null fields are blue and the white ones can be null. Okay? There is another key in the job current and the job desired, but they're red in color. What it is saying is this. It is a primary key and it is also a foreign key. So in the same table, it may be a primary key and it is also a foreign key. It may happen, it may not happen. But red says, so the key symbol says it is a key. Yellow says it is a primary key. A red one says it is a primary and a foreign key. Okay. Now, this is one of the ways you can draw a diagram. I'm sure there are more software programs out there which you can do. I've only used Workbench because that's what I've used for teaching this course. And job listings is not related to any of the other tables. What is that? This is indexes. You will notice that in all the indexes, it will say the word primary. What is an index? An index is the normal English word index, like index in a book. It helps you to look for something in your table. And it says that by default, I've created an index on the primary key field in every table. So when you create a primary key, by default, an index is created on it. And what does index do? Makes search easy. And it assumes that if you've made it the primary key, most of your searches will be on the primary key. So therefore, it creates an index. Like an index at the end of a book. You want to look for the word correlation in a book. You go to the back of the book, look in the index. It says it occurs on pages 5, 10, and 15. You straight away go to 5, 10, and 15. That's what an index is, right? So the index helps you to search, makes search easier and quicker. And by default, indexes are created on every table on the primary key, which makes you think, can I create another index on a table? Sure, you can. There is a create index command to do it. So the diamonds are just normal fields. Blue says not null. White says I can be null. Key symbols means it is a key. The yellow one says I'm a primary key. The red one says I'm a primary and a foreign key. These relationship lines say that there is a one-to-many relationship between the contacts table and the job current table, right? And the one-to-many between the job desired and the total contact says there is a one-to-many relationship. I haven't put many on the other side because my table design doesn't allow it. But it says, oh, one contact can occur many times in the other table, which is logically okay. So it's just doing a logical definition of what it has seen in your table. Now, this relationship, one-to-many, there are 3 kinds of relationships that can exist in tables. One-to-one. There is only one-to-one match. One contact ID can only occur once in the other table. That's actually what ours is. We haven't had, because that's our primary key. Second, one-to-many. And third, many-to-many. 3 kinds of relationships can occur in between 2 tables in a database, in a relational database. These lines can be drawn in different ways. If you want to see another way of doing it, if you go to model and you say, relationship notation, you can use the crow feet. The crow feet looks like this. like a crow's feet, which is many, right? A crow has the feet, the foot of the crow looks like this. So that kind of represents many. So it can also be drawn this way, where it says one on one side and it shows many on the other side. That's like a crow feet, 3 lines, they've done it like this. Similarly, you notice there is no relationship between job listings with any other table, and there isn't. So it doesn't show. That's another way you can show it. There is a third notation which you can use, which I haven't ever used, but this is a third one, which is called classic. And it looks like this. So what it does, it puts a 1, and on the other side, it puts a 1 dot dot star, which means 1 to many. Right? So that's what it is saying. And I'm not sure what this diamond means. I've never used it. I can look it up if you like. But I prefer to use, it's my preference, I prefer to use this one for 2 reasons. One, it shows me the field also that is related, connected. Notice how it is going from my contact ID there to contact ID here. So even if I had called it something else, contact ID 2, contact ID 3, or anything ABC, the line would tell me that these 2 fields are related. So that gives me an idea of which 2 fields are related. It is only shown in this notation. The field is connected to the field. And of course, the 1 to many, the many is the infinity sign, says that it can be a 1 to many relationship. It is not in our table. Our data is not doing it. Just because it's the primary key also, it will blow up. But that's what it infers from it. Now, in the real world, the ERDs are drawn first by the developers and then passed on to the programmers so that then they can just code it. So now if I look at it, I know I have to create 4 tables. I know exactly what their names are. I know what the field names are. I know what the types are, and I know what foreign key constraints I have to create. So the developers will do this and pass it on to the programmer. Or if, of course, the developer and programmer are the same team, they'll do this first and then they'll do it. And you'll say, can I do it in MySQL? So of course you can. In model, you will see you can create a diagram. You can start a new diagram. You can add a diagram. So there are different software packages out there that help you to draw the diagrams. I just cheated. I kind of went the opposite way. My script was ready and then I'm drawing it. But you should know how to draw an ERD by hand or using the workbench or using any other software program. But when you submit it to me, and I will be asking ERDs from you in the assignment, when you submit it to me, you have to tell me what is yellow key mean or what does blue mean. If you don't have a colored printout, they will all be black and white. So don't expect me to understand what they are. I'm explaining it to you what they are. When you give it to me, you make a legend for me. So you can color them if you like, or if you're taking a black and white printout, then you have to think of something else, right? But yellows are primary keys, reds are primary and foreign keys. The others are just normal fields. The blue ones are not null fields, and the whites are just normal fields, right? So it gives you all information. An ERD gives you all information. If I give you this ERD, you should be able to write a script for me. Vice versa. If you give me an ERD, I can understand, oh, this is the structure of your database. So I don't have to go and kind of look at each of your field. I can look at the ERD and say, oh, this field was supposed to be not null and they have made it null. I can just look at the ERD and make educated guesses. So anything that is blue is not null, white is null, and so on. And this is what you've done. You've created relationships as I asked you to do, and everything looks right. So when the assignment, which will come next week, after I finish next week, I'll give the assignment and I'll ask an ERD from you. And it is very helpful. When you do your assignment, print an ERD and keep it for yourself, because now you will see after the break, when I start doing joins and subqueries, I'll keep referring to my ERD. I don't want to refer to the script. Who wants to read the whole script? This is easy. It tells me the field names, their types, whether they are null or not null, and what is the relationship between the fields, right? So we'll take a break here, but this is the basics of starting to use multiple tables in a database, and this is called an ERD. So if you give it to me, please remember to create a legend for it. You don't have to use MySQL Workbench. If you know of something else, you can use it. But a legend should come to me to explain me what it means. Okay? So we'll take a break here of 20 minutes. Have your whatever break, have your tea or whatever, or what do you want, and then come back, and then we will start our script. We will start writing the script, and we'll start doing select statements to start with, because now you have to start joining tables, right? And I'll show you how to join the different tables. And this ERD will come handy. So I'll keep it open and I'll refer to it when I answer the queries. Okay? Okay, so if you've understood the concepts, you should be ready to go ahead.
In my course, so good you make the legend with the ERD.
Wait, what?
You don't have to make a legend for the ERD.
Make a legend? I didn't even pay attention to that.
You said something like that. I don't know, because the next time if you're a sim and you gotta print off the ERD or something like that, and send it to me, and I want a legend with it. Okay, what?
That was the. Well,
And I just want to go to how, like, I don't want to, like, go through all your code and mark it. It's like, what?
yeah, I heard that first. Whatever.
She's like, I know that's my job, but I don't want to do it.
It's super tough. You don't want to do the whole thing. No PHP anymore.
No,
So pumped.
I'm gonna wake up still and watch that video.
I probably will too.
Probably like 10, 9, 8.
Yeah, but I was gonna say I might be at like 9:30. Then I gotta make my sheet for
I'm gonna do my
Java.
sheet today. I'm just gonna copy and paste from his notes for stuff I don't know.
Yeah, I don't think it'll I don't know.
I
I don't think it'll be too hard.
most of it was simple.
Yeah.
Most of that, one of the questions was, what is OOP? And that was the first question. It was OOP.
Okay. Well, I was trying to think about like a lot of stuff we learned was like just kind of touching on like what we did and drilled into the class.
Oh, God.
So that was one thing, all the terminology and stuff, but like I'll never forget it because like
All we did was scream about it.
instantiation.
Instantiation. Yeah.
Oh, you're wrong. Did you finish your PHP assignment?
No,
No.
I never really heard it.
Neither have I, but I'm very glad it's not just me now.
Don't work it.
I don't think like I don't really know what the FBC is all about yet, because I skipped last week.
It's basically like, instead of having all your delete functions in one table or one page, it just calls your delete functions from a different page. So like you have delete, add, and list in one page. And you have another one that's just like your input thing, but it calls stuff.
Was it pretty simple?
Pretty simple.
Yeah.
For example, is basically what you need. If you did for example and based off that, you're pretty good.
Okay, cool. Yeah, I haven't even looked at it. Well, all I did was Google like what the FBC is all about. So just to, cause like, so last week I friggin', cause I guess PHP for Millennium got canceled last Thursday. So I'm like praying. I'm like, oh, maybe ours will get canceled too. So all of a sudden I see the cancellation for Java, but I didn't read what class it was for.
You're like, oh,
So I sleep in and my brother's like, are you covering it all today? I'm like, well, we gotta write the intern layers. Yeah. He's like, what? Dude,
No.
you're fucked up. He's like, you're supposed to be a PhD right now. And I'm like, nah, too late. It's already 9:30. I'm like,
I think something big happened to Ben because that cancellation seemed really bad.
yeah.
Oh, I thought he was like, I'll have someone come in and you guys will read the midterm then.
True.
But I think no. Oh, I'll wait. Yay!
Yeah, I was not.
I hate having midterms when the teacher's not there.
Oh god, yeah.
Wait, is that? I did these. I tried this. This is a math midterm and the teacher wasn't there. I remember writing it midterm and the original teacher wasn't there.
Last semester.
Could have been math.
I didn't wait for math. Like, fuck that guy would miss a class.
Sucks to be you.
It was good, honestly, for math. It was like, it worked out really good that way.
I had the funniest guy that said like his name. He was hilarious. He'd rip on Mo all the time.
Oh, that skinny older guy.
Yeah.
I used to walk by his class all the time.
Fucking ear stud in there. I didn't know until the third week when I walked up to him, tell him a question, ask him a question. It's like, oh, ear stud.
That's all you can focus on.
Honestly, that's all I can focus on after a while.
Catches the light right when
I would agree on dropping some short with my dog.
have you fucking had much luck with your co-op or anything?
No, I've only applied to 2 now, and I plan on applying to the second one, but I don't because I'm the king of procrastination.
Oh, dude, that's me right now. Like, I've had 2 opportunities now that I could have applied for, and I just like, see ya.
I would do another one come up this weekend, but no.
Yeah, I should. I gotta get on it. I mean, it's not. Very intense right now. We're getting to the point now.
Yeah.
Within 2 weeks, I should start stressing.
Yeah.
We'll see.
It's like,
I don't mind taking a rinky dink co-op though, to be honest with you.
in the end, it's like impossible. You just cannot get co-op. They're not gonna punish you.
No, I literally.
Like,
I'll
obviously-
just take full time.
obviously,
job and get them.
Yeah, if you have like, say you've only looked at 3 job postings in the last 2 months, okay, maybe that's something. Maybe that's their fault. But if you looked at more and you just can't get one, then maybe.
Yeah, that's true. That's true. Yeah, I could just make up. Like, I was trying to find a local one, and by the time I was done looking local, all the other ones were filled.
I was trying to find a local one because the car I have can't really go past 5 hours, like an hour drive without breaking down. So
Just sell it. No, I think I should do it online. So, like September 8th or something like that.
because I know that midway through June, or like in the first 2 weeks of June, Rod sent out an email to everybody. I don't know if you didn't see, but it was like, those looking for summer co-ops gotta find a job now. Like it's midway through June, like, oh, wow.
That's funny. That's the one thing I was thinking, like, if you could just get your employer to like say that, yeah, we're tech related.
I can't go and get a lifeguard. That's not gonna work.
Yeah, that's kind of.
We're tech related. How? Robot lifeguard.
Or data entry, gonna log all the patient's name. Text file. I don't know.
Scrapping on the website.
Don't close it. It is employed Georgia, right? Not Oregon.
Yeah, it's a clue.
I've been going here and
There's one at Boardman to apply to. The one, the criminal, like, isn't calling for it.
that's not too bad.
It's not 45 minutes away.
Let's call it nice. It's a nice drive out there.
Yeah.
Oh, are you doing the Talent and Associates thing?
Yeah. computer technician.
Is that hardware?
Yeah, that's hardware. Certain things are hardware.
That's false.
Did you go to class yesterday? C sharp. That's assignment for you.
Yes, first.
You got a score for how about the first one?
Yeah.
And he already did this the first one. Yeah, I just see the victim score.
Oh my god. Like, walk at me driving a hit. Oh, shit.
And if you are not going to call. You choose like 100%. It's just the one that you can show that that's not like. I see the requirements next week. I see something very, something very.
It's not fucking remote. Yeah. I can't tell when it sounds like it's like like you're literally just like one of those help desk people.
Something, yeah. Some of them literally are that. Some of them basically say, oh, you'll just be now helping people with their computer problems. Everyone turn on, start eating some coffee on this laptop. My friend did go up in the city of Barry City Hall, and he was like, that's basically what it was like, fixing computers when people had problems with them. Like he said, one guy came in and it's like, my computer won't turn on, and he said the guy had this whole computer covered in coffee. Bruh.
That's good. Couple cool.
Yeah. I only know there's like 13 put for us.
Yeah, that's still just 13 of them. The RBC one doesn't sound bad. It's not for developer.
The board one seems okay. Seems like
Doing like so, yeah, 1208 an hour. Isn't that under bit okay?
I did under minimum wage, but it's, I think that's the board one. Right?
Yeah,
I think it's what the government.
there's nothing. It would almost be more strict.
You need government benefits, and that's why they're getting away. It's also military.
You taking those home.
Maybe it's in a negotiable.
Yeah. Give it a sign.
Maybe something they don't down on me. Yeah, that's been too bad. Special care. So good. When you do that, essentially, good. I'm sure. Isn't that good? And everything's going over. Not really. How does that work?
Yeah. I'll just go home and watch some Breaking Bad.
Much better call Saul too. People recognize you from Breaking Bad, Better Call Saul, or Church of College.
Yeah, for real.
They strangle those people with the DNC.
Okay, guys, let's move forward now. Let's start to write our joins and learn a few things so that we can move on further, right? Okay. The first one says use union. So there is a union verb already available in MySQL and also in other relational databases. And as the name suggests, like in math, union means unite, right? So everything from everywhere. So it says to get all possible job titles from all the three tables, leaving my contacts, the others are three tables, right? So what is union? Just to give you an example, may not be always useful, but if you need it, you at least have it. So you want to select the title from the table job current. You want to union. So difference between union and union all, remove duplicates and keep duplicates. You want to select the title. It could have been called anything else, but of course, if you're trying to unite something, you are not going to unite apples with pears. Apples with apples is what we are doing, okay? Then take the union of the title from the job desired table. Sometimes you may need it. It's an easy one. You don't have to do anything of your own. If I had to write it using a join, it would take much more time, okay? And I'll show you what time, like, why is this easier? So if there is a requirement of doing it, that you want to pick up a field, which of course makes sense to pick up and unite them and keep them together, for whatever reason, you're just interested in seeing what jobs people are doing, what do they desire, what's in the listing. That gives you a union of all the titles, right? And again, when you take union, you're basically trying to collect the thing of the same nature. So I'm taking title from the first table, title from the second table, excuse me, and title from the third table. If I run this script, run this query, I'll get a table with all the titles. So it just tells me what's out in the market. People are desiring these jobs. People are working in these jobs. There are listings. Just a generic idea. I will, once I do a little more, then I can come back and show you how I'll do it using join. Like, let me kind of just do what is already available. Now, there's another one which is called intersect or intersect all. Unfortunately, it is not available in MySQL. But if it was, this is how you would write it. So, and it is handy. It says, tell me what jobs are common in the two tables, listings and desired. So people are looking for jobs and people say, are they in the market? So it's a valid question. It's a valid question. What jobs are available and what am I desiring? Again, intersect and intersect all, as it says duplicates and no duplicates, okay? So it's a very interesting question which says what job titles are common in the two table job listings and desired. In other terms, the question is which desired jobs are available in job listings. So I put it in 2B. That's what I'm trying to do in 2A. Unfortunately, if it was there, this is how I would do it, as simple as that, but it's not available. So now I have to write my own join statements. Once I do that, I'll come back and show you how to do the join of these three tables also. Okay, you can join any number of tables. So the intersect is not available. So if it is not available, can't do much about it. Languages that have them, or not languages, relational databases that have them, like RBDB, Oracle and DB2, that's fine. So now I'm going to answer the same question, but since there is no intersect, I'm going to kind of, answer it in my own way. Let's see how I answer it. And here we start our joins, okay? So as I said, guys, this is important that you get this class very, like, thoroughly, because what you do today is going to be important throughout as you do it. Okay, let's look at it now. Which desired jobs are available in job listings? And it's a valid question. I'm looking for a job. I want to see, is it available in job listings? Do I have a chance? Is it out there in the market? Right? So think about it. Job desires are coming from which table? Look at your ERD. Job desired are coming from which table? The job desired table. Where are the listings? In the job listings table. So what are the two tables you are interested in? Job desired and job listing. Okay. Now the question simply said which jobs are available. So basically you're looking for titles. You're looking for title. So I'll go step by step so that you can understand it. So I want to select the title from which two tables? Now we have two tables, right? From the job desired table and from the job listings table. I want to do a join between these two tables. I have to join them. Is there a joining condition? Of course there is. I just don't want to say hello. Now let me do this without a joining condition. I'm just saying, give me the title from, let me put a star to begin with and tell you to see what happens. What does join do? First, let's understand what does join do. And for your information, this is also called a Cartesian product. Not very helpful, but it is available, so I'll show it to you. So this is just to show you how join works, what happens in a join. So I've said join the two tables. That's all I've said. Okay, let's run it. I've said join the two tables. See what happens? Look at the number of records. And how do I determine how many number of records? Look, go back. The job desired table had 1, 2, 3, 4, 5 records, right? And the job listings has 14 records. 14 into 5 is 70. You should have 70 output records. 70 output records. What happens when I join a table? Every record in the first table says hello to all the records in the second table. Then the second record says hello. It's like we are all sitting in a room and everybody says hello to everybody. That's what a join is. That's what a join is, right? I don't have a condition. I just say join hands with everybody. So what will you do? I'll stand up and I'll join hands with each one of you. Then the next student stands up and joins hands with each one of you. That's exactly what a join is. So a join is useless unless you just are interested in this. Everybody says hello to everybody. So what I showed to you was a Cartesian product. It is an inner join, but it is a special case. What is a special case? There is no where condition, right? But it's not very useful. It will become useful. It will become useful if I add a where condition to it. So this is just a Cartesian product, okay? Nothing else. That's not the answer of my code yet. Now, if I add a condition, you tell me what condition do I need to add? Who should say hello to whom? Which records should be joined? I'm looking for people who desire a job and to see if that job is available in the job listings. So what do I need to compare? I'm looking for a job for computer professor. I want to see if it is available in the job listings. Is there a computer professor listing job? So what do I need to compare? Come on, when you're joining and I'm saying which title, which desired jobs are available in job listing, what do you need to compare? The titles. The title here should match the title there, right? So write that condition. And you will say title in the first table is equal to the title in the second table. But that's ambiguous. Which title? Like whose title? So what you do is you have to go, since the field names are same, you will say the title in the job desired table is equal to the title in the job listings table. I'm only interested in those records. So say a hello, but only say hello if your titles are same. So that will tell you these jobs are desired and are available. So let's try that now. So this is called the joining condition. Good. Baker was looking for a job. There is a baker job. 7 was looking for a computer programmer. There is a computer programmer job. 8 was also looking for a computer programmer, and there is a computer programmer job. So notice 10 says hello to 1. 7 says hello to 13. And 8 also says hello to 13 because the titles are same. Right? Now, the best I could do is, since it is text data, I should be trimming my data just to remove extra blanks in both of them. With text data, it's a good idea that you trim extra blanks on right or left. Otherwise, it won't match. Right? Otherwise, it won't match. Unless, of course, there is some set condition that says, okay, ignore extra blanks on right and left. Maybe you can Google it and see how to ignore extra blanks on right and left and make it like there is case insensitivity. Maybe there is something, and I think I read about it. I can't remember right now. And that's it. But now I'm seeing everything. What am I interested in is only the title. But look at something. Titles here are same as titles here. Definitely, because they're the same. My condition is equality. So they're the same. So now whose title? Which title? Because there is a title here, there is a title here. So again, to take care of ambiguity and to make it unambiguous, so when the field names are same, ensure that there is no ambiguity in the field name. So which title do you want to pick up? You can have picked it up from anywhere. You could have picked it up from job desired, which is this table. The first half is till here, till salary, hire, and years of experience is the first table. And then job ID, title, salary, zip is the second table. They've just joined together. All the fields they'll all come on the screen. If you're interested in particular fields, only pick that up. And if the field name is same, give it a qualification. Otherwise, totally. I mean, it will make no sense if I tell you room equal to room. You'll say, what is she saying? If I say room 1 is the same as room 2, then it starts making sense to you. So you have to qualify the name of the field if they are the same. So the option is you don't keep them same. But some programmers like to keep them same. Why not? Because it's title. Why should I call title 1, title 2, title 3 because I don't want to write qualifications here. But again, it's up to you. I'm not forming a rule for you, but this is how I would do it, in the sense that how I have created my table, I have to qualify your title everywhere I use it, because I don't want any ambiguity in my code. Okay, this is one way of doing it. Another way of doing it is this. If the field names are same, which they are, right? Title and title are same names, and equality and joining condition. This is your joining condition. The where is your joining condition. And joining condition is equality. You're doing for equality, which we are doing. Then you can also write it like this. You can write the same statement like this. Without the joining condition, but instead of using the word inner, you use the word natural join. So you don't have to give a condition then. But the condition is by default what? The condition is you are comparing the same field name for equality, and it won't take care of, it's an exact match. It won't trim the fields. It won't do any trimming. So you have to be careful. If one has a blank in front of it or after it, then it won't match. It's an exact match, character to character. Right? So extra blanks, padded blanks will say I'm not equal. That's a drawback with natural join, but that's what it is. What could you do before you even do it? Take your field, trim all the whole field, trim the fields before you start working with them. Take all your character fields and trim them. select, trim, and then just update them. So update a field, trim it, and put it back. I could do that, and then my natural join will work perfectly fine. But it is an exact match, including blanks on either right or left. But it can be avoided. It's not a big deal. Before I do this, I could just, if I wanted, I could just update it. So I can say update my table, set the title equal to trim title, and it would remove it. Then I'm okay. Then I'm safe, right? So if you want it, you can update it. Before you start doing it, you can update it. Update my table. Both the tables have to be updated. Your job desired table has to be updated. You can set your title to trim my title. What will it do? It will remove all extra blanks. Maybe there is a better way. I can Google it and see, but this is the easiest one to do right now as it comes to my head. I'm sure there will be some kind of setting that you can do and say, oh, I don't want this. So I can update my two tables, and then once I've updated them, then I'm sure my natural join will work automatically. Then I don't have to worry. But natural join will only work if the field names are the same and you are checking for equality, nothing else. Right? So I've trimmed them, and now I know once I've trimmed them, I'm okay. I'm sure we can look it up. I look it up today, hopefully. I keep forgetting. This is a second way of doing it. There's another way of doing it. Oops, wrong one. There's another way of doing it. So I'll take the same thing from here. I'm going to repeat it here. I'm going to say 1, 2, 3. Okay. So that's one way of doing it. A. That's a B. Just showing you different options. That's a C. And instead of the word inner join, oh, sorry. The C, the select should come on a different line. The select should come on a different line. The select should come on a different line. There, right. The third option is instead of the word inner join, you can put a comma if you like. Easy. Saves you some typing, but some people like it, some don't. Okay, a comma instead of the word inner join. So you can use a comma. And some people say, oh, these are two big names. Like, I mean, do I type them or do I copy and paste every time? But there is always help. As soon as you start typing, a list comes and you can choose from it. But you can choose alias names if you like. And what are alias names is this. You can use it anywhere. I mean, it's not only in comma, you can use it even in inner join. You can use alias names. And what are alias names? You start giving them short names. Job desired becomes JD. Listings becomes JL. So wherever now you use, you can use JD here. You can use JD here. You can use JD here. Actually, I don't even have to trim them now because remember, I've already updated them. And either comma or join are required. So you can use, I mean, you can use alias names with anything actually. Not only with inner join, you can do it with outer join and natural join, anywhere, wherever you need them. So what happens in this case is the names are shorter, so there's less typing to do. Though, as I said, as soon as you start to type, a list comes, you can select from the list. You don't have to type the whole thing, but that's an alias name. So you can give an answer in 5 different ways, in a sense. You know, you can use the word inner join, you can use natural join, you can use comma instead of inner join, And you can also use alias names, whichever you like. My aim is to just give you the options so that, and again, I won't keep writing all the solutions for every question. Whatever you like best, you can choose from them, whatever you like. Okay. Now, if you notice the computer programmer, we haven't run it. Let's run it for once. We haven't run it after we've written all the 5 options. Notice how computer programmer is coming twice. Oh, this was, what's this one? Oh, some error. Was it interrupted? Yeah, I have an error somewhere. Oh, it says you're using safe update and you try to update a table without. Oops, I wasn't going to update ever and therefore I had removed it. But now that I updated it, I have to kind of remove that comment. There. I thought I was not going to update anything because I was doing joins today, but I just updated a table. Okay, so what's this one? It's again, is it interrupted? No, completed. What is the last one?
You put JD equals JD.
Okay, okay. You can always stop me when I'm doing it. Thank you. So something is wrong. My answer is not right, so something is wrong. So Brad has his eyes on it. He said you put JD on both sides, whereas I should be saying JL, right? Okay now? Okay. Once more. So it ran, it just ran. So here notice, same answer, same answer, same answer, same answer. And of course, this was a different one. This was the union. So all 4 are giving me the same output. The only thing that I can improve, you don't have to, I mean, unless it is asked. The computer programmer is coming twice because there were 2 people who wanted to be computer programmers and they found a partner in the job listings. If you don't want that, you can always, if you want, I'll put an option here of E and say show each title only once. Remember what we did? We used a distinct last time. So I'm going to copy this just because it's the nearest and put distinct in front of it. This is not a rule that you have to only appear once. It depends on what you're doing. Maybe this way I'm saying, oh, 2 people are looking for computer programmer. This gives me an idea that there are 2 people looking for computer programmer, or vice versa. There are 2 in the job listings. So again, I don't know which could be true. So if it doesn't matter that all I'm interested is in people are looking and there are postings, then you can say distinct and the computer programmer will only occur once. Okay, so I'm still keeping trim here because this update was just done. So I can put this in comments just because, I mean, I can write. You can always remove extra added blanks. Like this was just to show you can do it. It's not as if it's not doable. And then you can use a natural join. That way you will always be right. I've removed it because I'm using trim and trim and trim afterwards also. So the whole purpose of update is lost. I'm keeping the trim so that you don't forget. Whenever you work with alphanumeric or text fields or string fields, whatever you would like to call them, it's always a good idea to remove the extra blanks on both the sides. Unless, as I said, we can Google it and see. I'm sure there is some way, not the trim function, move blanks from string or varchar or char. Same thing will hold in MySQL. There is something which says remove blank spaces in varchar. I'm trying to look if I can find something in the manual. The char and the varchar are similar but different. They are stored and retrieved. They also differ in maximum length. We know all this. Oh, when char values are retrieved, trailing spaces are removed. automatically, but trailing, not beginning. See here, this is where I read it. If the SQL, if strict SQL mode is not enabled, and you assign a value to a char or varchar column that exceeds, oh, that's no, that's talking about something else. A warning is generated. Oh, it won't give you an error. So SQL mode is helpful to be strict, because then if I try to give something bigger, it will give me an error, not a warning. In varchar columns, trailing spaces in excess of the length column are truncated. Yeah, that makes sense. It's not only trailing, it's also leading we are talking about. Oh, well, so it's not in a set. InnoDB. Okay, and that's not what it is saying. I mean, the trailing there, you can remove it. Not using strict mode is if MySQL is running in strict mode, values that exceed the column length are not stored and an error results. So that's another use of now making it strict. It helps you catch your errors. So if I've set char 5 and I'm putting Anju Chawla into it, an error will come up. If I don't say strict mode, it will save Anju blank in it and it will work. Just give me a warning. So strict mode is good. It is better to use strict mode. But I don't see where they're talking about trailing blanks, not talking about leading blanks. But we have an option. We can always do update. Anyway, didn't find a solution for that. But now this one, at least we know one use of this one, which is good. Another use, not one use, another use of strict all tables. Strict all tables will not truncate data and save it. It will give you an error if you try to save more in a less field, right? So which is good. If I remove it and I try to make this something small, see, I'll show you what it means. So I don't have this, okay? And now I change my varchar last name to 3. Now 3 is too less. I'm sure we have more than 3 last names. And then I just take this and run this script till here. Oh, it is still saying data too long. So what's the sense then? Strange. It said it will only give you a warning. Oh, well, the manual doesn't seem to be saying correct then. Anyway, why should I bother in terms of testing what the manual says right now and waste your time? I'll do it when I have to do it. Anyway, right now it's more important to understand joins. So you understand what the join is? The most important thing to remember, which a few students will always forget during an exam and during an assignment, the joining condition. If you don't put the joining condition, you get a Cartesian product. And of course it is wrong, right? So you have to be careful that your joining condition is always present in your query. If I miss it, my answer is wrong. Okay, so choose whatever you like. You like the comma style, you like the inner join style, you like the natural join style, you like alias names, you don't like alias names, whatever. But this is how you would do it. So I've given you 4 different ways of doing it. Now let's look at number 3. It says, give me a list of job titles that are desired but not in the listings. So somebody is looking to be a DBA and it's not in the listing. So it's the opposite, right? The first one was saying the job is desired and it is in the job listings. Now it is saying the job is desired, but it is not in the job listings. So the first thing, I don't know what comes in your mind, but the one thing that a normal person would say, oh, now I want to join on that the titles are not equal. That's what I want to join on now. The titles are not equal. Before the titles are equal, but here now the titles are not equal. But I'm going to show you something that this is not right. Logically, this is not right. But why? Why is it not right? Because every record will be picked up. Do you match? No, spit it out. Do you match? Yes, don't spit it. You match with the third one? No, again spit it out. So it's saying pick up a record from the first table, job desired, match it with all the records in the job listings. If a match is found, don't print it out. If a match is not found, displayed. That's not what we want, right? So let's try it. I mean, logically, this is what we'll say. Oh, we don't want to match titles, but see what will happen with this. I'm not sure if I ran it after saving the whole thing. That's absolutely incorrect. So that's not what we want. We want two people were looking for jobs that were not listed. So computer programmer and baker are listed, but there was somebody was looking for a chef, I think, and sales manager. So the answer should be sales manager and chef. And here is the answer I'm getting: 67 records. Doesn't look good at all. So that means that's not the right answer. But as I say, that's the first thing that will occur in your mind, because you're saying, oh, now I don't want the titles to be the same. The titles are unequal. But that's not how it works. So there is no solution for inner join in this. So we are now going to learn a different join, which is called an outer join. Okay, so it's a little tough, but I'll do it step by step so that you understand what I'm doing. And please follow it. Okay, so this is an incorrect. This is an incorrect solution. I've seen students doing it, and I'm bringing it to your notice that, yeah, even maybe a few of you thought, oh, that's all. We have to now check for not equal. That's fine. That's what comes into your head. The first thing you think about it. But that's not the solution. What we need now is an outer join. Outer join comes in two flavors: a left outer join and a right outer join. And let's see what outer joins are. So I'll show you steps, step by step. I'll show you what an outer join is first, okay? I'm going to select everything from the two tables. And there is a difference between a left outer join and a right outer join, and one is more efficient than the other, and we'll talk about it once I show you what it is. And the condition has to be put using the word on, not where. Okay, so the condition, the joining condition uses on. All other conditions use where. And what is the condition? The condition is that you will say, that doesn't look right. I'm not joining on join. I'm not saying, oh, join when they're equal. I want when they're not equal. But let's see how left outer join works. That's what is important. Left out and what is left and right? The left outer join says this table is the master table. So the record, the first record from this table will be picked up, will match with all the records in the other table. And if it gets a match, you will see the result. If it does not get a match, you will still see a result with something, with nulls. Okay, so I'll show you. The second record is picked up of the master table, joins with every record of the second table. I chose to use desired as my main table because desired was a smaller table, listings was a bigger table. So I'm thinking this will be more efficient, right? Because I'm trying to pick up records from the first table, which are less, and comparing with all of the second. So sometimes you may, now again, you're not professional database programmers, but in the long run, if you are and you get experience and you keep working, you will know that this will work more efficiently than this. The efficiency difference could be 5 seconds, but 5 seconds mean a lot when you're working with trillions of records and people are using your database trillion times a minute. Okay. Okay. Now let's see what it does. Look at the output now. Okay. See what happened. There was a baker in the first table. He found a partner. There was a computer programmer in the job desired table. He found a partner. The computer programmer again found a partner. Doesn't matter the same partner, or if there were more of them, it will partner with everybody who is the same. Sales manager couldn't find a partner. What did it do for the fields from the second table? It filled it with null. Chef couldn't find a partner in the job listings table. What did it fill it with? Null. Now, of this table, which records do I want to pick up? Which are relevant to me? The first three are relevant because they're telling me which jobs are desired and are available. The last two I have to remove. Right? The first three tell me which are desired and available. The last two I have to remove. How can I remove them? What do they have in their field? Null. Let me use that condition to remove them. Okay, so let's do step number 2. So step number 2, so this was to show you what is an outer join. So understand what is an outer join. Every record of the first table looks for a partner in the second table. If it finds a partner, it joins hands. If it doesn't find a partner, it puts null in those fields. I couldn't find a partner, it says. Computer programmer was able to find a partner. There could be more than one partners. It will join hands with all of them. You will have as many records as it joins hands with. If it cannot find a partner, you will notice that there will be null in those fields for the second table where it couldn't find a partner. So now if I want to remove them, all I'll do is I'll add a where condition. So which ones do I want to pick up? I want to pick up those records where the job ID is not null. Why am I choosing job ID 1? Because it is the primary field. You could use any of these fields. Really doesn't matter. But again, we work with primary fields when we can work with them. If the job ID is not null, then I want to pick it up. So which records will be picked up? The first three. Job ID is not null in them. I repeat, you can use title, you can use salary, you can use zip. Any of the fields is not null will work. Because all the fields are null for the second table. Job ID just because it is primary key and it was occurring as the first position. Now let's see how it looks. The last two records should go away. There, they go away. Now I am interested in only the title. I wasn't interested in everything. I'm only interested in the title. So now let's do step 3. And instead of star, what will I do? Title. And whose title am I interested in? They're the same. The title here is the same as the title here. Doesn't matter from which table I pick up. So you can pick it up from wherever. I'll just pick it up from job desired, just because it's my major table. Major means it's the important table. Because I thought it will take less time to do. There it is. Now when you run it, you will only see the titles. And that's my result. So these are the titles. Oh, sorry. I'm so sorry. You were right. I'm sorry. The question was, which are there but not in the listings. I'm sorry, Brian. Right? So we should say where job title is null. Whoops. I'm looking for jobs that are here but not here. Is null. I was answering 2B in 3. Is null. Is null. Okay. So I'll repeat it. Sorry. I'm so sorry to confuse everybody. Here, we'll run it again. This is an outer join. Shake hands, find a partner. Yes, don't find a partner, null, 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 null. As many fields, everything is null. I am interested in the last two records because the question is people who are looking for a job, but it is not in the listing. Okay, so how do I do that? I want to pick up these ones only. So the job ID should be null. So job ID should be null. It will pick up sales manager and chef. Right? And I'm only interested in the title. So now pick up only the title. There. So sales manager and chef are desired, but not in the list. Okay, done. So why did I show you 3 steps? So that you understand how outer join works. Now I'm going to do the same thing using a right outer join. There is something called a right outer join also. So make a copy paste, change it to right outer join. Change the left to right outer join. You could have changed the table positions also. The difference between left and right is this. In the left outer join, you can make a note for yourself. The table on the left is the master table. I hope you understand the meaning of master table. I mean, it's the table which is kind of from where you're starting your comparison, right? In a right one, the table on the right is the master table. You'll say, how are they different? I mean, they will work the same way, they will, but I'll show you the difference. So I'll put a note here. The table on the right is the master table. And I'll show you the difference. Look at the difference. I'm going to run the same query now that I did before, but using a right join. There you had 5 records. Here you have as many in the job listings. Because listings had more record, it had to go, each record was picked up and it tried to find a partner in the smaller table. This itself tells you that this is less efficient in this case. When more records are coming, more results means it did more work, right? So the first one had 5 to begin with. This one has, I don't know, you can always check how many it has. It has 15. It always shows you in the lower window how many. It has 15. Because it picked up a big table and it says, are you there? Are you there? So it had to check 15 records. In the first one, it only had to check 5 records. So in our case, this right outer join is less efficient. So it is important to understand that which table should be my master table. Doesn't matter which one. You can place it on the left and use the left outer join. You can place it on the right and use the right outer join. You can use either joins. But you have to always choose the right table for being the master table. Maybe not right now because you're just new to it, but definitely if you can see the difference, you will see why am I stressing to use the right table. In one, 5 things had to be checked. There were only 5 records in job desired. In the other 10 had to be checked because it had 10 records or 15 records. So definitely who's doing more work? In this case, right is doing more work. Right? Now let's see the same thing. So now see what? So whoever found a match, it's okay. But whoever didn't find a match, you see null here. Same thing, right? You see null here. So this person, clown couldn't find a match and so on and so forth. Lawyer couldn't find a match. Salesman couldn't find a match and whatever. All these couldn't find a match. So I'm interested in these, but I only want to pick up where my, what is null now? Contact ID is null now, right? Because there I was picking up job ID. Now I have to pick up the contact ID. So let's try that now with the right outer join. And you can pick up anything. It really doesn't matter. Just look it up. What are we interested in? People who need a job. Can we even answer it using a right outer join? Think about it. Can I get the answer? If I pick up who are not null, it doesn't work. If I pick up who are null, it still doesn't work. Because then all these records will come up. Everybody will come up. Clown will come up. Dog trainer will come up. Hairdresser will come up. Jeweler will come up. And lawyer, everybody would come up. That's not my answer. That's not the answer. That's a wrong answer, right? Even if I say it is equal to null, it is a wrong answer. I can't do it right using a right outer join, actually. I mean, I could, but then I still have to make this, I still have to make this as the other table. My major table has to be the same table. So this is less efficient, and it is not working even. It's not working even. So I'll have to do this. I mean, I'm just showing you right outer join for the heck of it, but it's the way I had written, it won't work, but this one will work. So the job desired has to go on the right. It still has to be the major table. It still has to be the major table. I can't use the other one as the major table because look at the result. How do I only now get salesman and baker out of it? I cannot. So if you wanted to use a right join, which you can, you move the table job desired on the right hand side. That's the difference between the left and the right. But the choice of the master table is very important. Keep this in mind. The choice of master table is important. If you don't choose it correctly, it won't work. Like if I made job listings my major table, it didn't work. It's not working. I can't do anything about it. Actually, this is a solution of your 2B. I can use it in 2B to make it work. But here it is not. So I just have to use the same thing. Now, the only difference, so at least I can show you that the only difference is right outer join, the right table is the master, left outer join, the left is the master. That's all I can show you here. Got 2 selects from where God knows. Maybe I was typing myself. Okay, so step number 1, use a right outer join, but notice this is still my major table. Step number 2, I removed where the job, okay, now let's run it and see what is happening first. It will be the same table. Okay, now I have to remove or I have to keep where job ID is null. Okay, I've kept it. And then I'm only interested in the title. So I keep that. Oh, title of what? You can pick it up from anything, JD or JL, really doesn't matter because at this point of time, they're the same. Yeah, so that's the difference between right and at least in this one. In this one, there is no major difference. So I can use either right or left, but the choice of the master table is important. I can't do it by using this as my master table. I couldn't. There was no solution. So I still make this as right. So see the difference between right and left. You just place the important table or the master table on the left or on the right. That's the only difference as per se in this question. The solution that I wrote actually could have done for step 2, which we will. Don't worry about it. I will do it. And let me now show you another way I can answer this query. I can answer this query using a subquery. So I couldn't answer using an inner join. I had to use an outer join. I gave you both solutions using a left outer join and a right outer join, just so that you know that majorly they're not any different. The difference lies in which table is the major table. And for us, the major table is the job desired table. Okay. Now the subquery now. And then I'll go back and do the 2B, which I had not done using an outer join. What is a subquery? A query within a query. And when you read it, when you do it, you'll say, oh, that's an easy one. We should have done this. But again, not everybody will agree because there is a question of efficiency in queries. Is it efficient or is it less efficient than the other one? And you write the most efficient one. Okay, so what are you interested in? You are interested in the title. From which table are you interested in? You're interested in from the table job desired. Right? Where this title, so if this title is not in the other table, it's like saying it in English. What's here and what's not there? So the TBL is missing here. And the listings is here. That's a subquery, a query within a query. Select this from this where title not in. Okay, I have a red squiggly somewhere. Select star, thank you. I can also say only title. The star will give me everything, but I'm comparing title with title. There. So what does it say? It says pick up the title from the job desired table, look it up in this one. And notice this is independent. I can just run it independently. The inner subquery can be run independently. These are titles in the job listings table. I can run it independently. I cannot run the outer one independently because it is dependent upon the inner one. And there is my answer. That looks very simple, but that takes more time than a join. Why? Because it is doing 2 queries. It first does the inner query, finds the results out of it, then plugs that result into the outer query and then gives you the result. So again, please go and read about are joins more efficient, are subqueries more efficient, and there is no general rule as per se. Why? Because it will depend upon what you're trying to do. It will depend upon what you're trying to do. So in this one, I did a select and then inside a select. So you'll say, how will I know? You can't know by just in the air. You can't know it just because you haven't practiced it. But as and when you start writing queries, you can always time your queries. We don't have that tool, but we can always say, oh, this query is taking these many seconds and this query is taking these. And maybe it comes in, see here, okay. It doesn't say, all it is saying is 0 by, so it's less than a second. So I can't make a lot out of it. But you can always see how much time it is taking, and then the programmer can make a decision as to what should finally go into his query. So of course it is testing, right? So he writes one way, he writes the other way, or she or he or whatever it is, and then says, oh, the subquery is taking 10 nanoseconds and the outer join is taking 5 nanoseconds. Definitely that is better. So I'll put that in my code. So efficiency is important because efficiency is important because you're dealing with tables, and tables have millions and trillions of records. So you're not thinking 10 records or 15 records. You're talking about a huge collection of data, right? So this is a subquery. So I've introduced you to an inner join, a natural join, which is same-ish, right? But same name, equality only. I've introduced you to a left outer join and a right outer join, and I've introduced you to a subquery. But before I finish today's lesson, I can start the other one, but I don't want to. The first answer that we were doing in 2B, which we had done using a join, can you now do it with an outer join? Remember, you had done this using an inner join. Now, can you do this using an outer join? So people who desire a job, and it is listed. Now try this. Give it a try, then I'll write it for you. So the 2B said, people, give me the titles that are desired and are in the listings. So inner join was the easiest one to do. Oh, we want to join on equality. And that was the most obvious one to do because you're joining on equality. But now I would like you to use an outer join and do it. And see if you can. And you should be able to do it. Oh, I didn't show you an except here, did I? No, okay. I've left out something. I will. In 3, though it's not supported in MySQL, I would like to still show it to you. Okay, try the outer join. Jobs that are desired and are in the listings. So you try it and I tried. So don't copy me, okay? Again, you can do it stepwise, one by one if you like. First, let's do a join. Let's see which records we are interested in and then look at the title. So you do your own. Don't look here. I'm trying it myself, but like again, I won't do it in steps. Hopefully I'll do it right, but I'll still try it in steps one by one. Use either join. I haven't said which join. But again, keep in mind which will give you better results, quicker results, not better, quicker results. I'm still taking my job desired to be my master table. I didn't want to do it at that time because I wanted to explain one by one. I'm going to see what happens in this one. Oh, where? On. Remember to use on with an outer join. Oh, I can show you something else also. As I do more stuff, I remember more stuff. Okay, so I should be able to do this and get it. And now people who need Don't forget your is and is not. It's not equal and not equal, okay? So people who desire and it is available. And again, distinct if you see them more than once. I'm trying both a right and a left and taking a different table to be the major table. You can try both and see what happens. Okay, here are my answers. If you have finished them, then you can match with mine. Here distinctly I did a left and a right outer join without doing anything. So I did a left outer join because I know this is my master table. It should be my master table because it's a smaller table. So when I do this, if I only do this, then I have 5 records in my table. Right? Or it's distinct, so only 4. But if I try to do a right outer join without the condition, I have 15 in my record. Oh, no. Oh, because I've already done. Oh, no. Okay. So now I can show it to you. With a star, I could show it to you. So I've written it this way. I've made this table as my major table, which I should, my master table. And in here, I've made this as my master table. But notice the difference. Here I've said job ID is not null, and here I've said contact ID is not null. Both of this should give me the same answer. So I've used right in the second one, but this is less efficient because I had more records in it. There were 15 of them. So here is something where you can answer using a left and a right, and the right is less efficient. See, you can kind of double, you can just try it without anything. Put a star here. So step number 1 was only this. That was a step number 1 without the condition, right? Gives you 1, 2, 3, 4, 5 records. That was step number 1 without any condition. And if I do a right join, oh, sorry. If I do a right join, what isn't it like? Select star. If I do a right join without any condition, I have 15 records. Right? So that tells me this is taking more time. But in the second one, my contact ID is not null is what I have to pick up. I have to pick up these 3 people, 7, 8, and 10. And in the first one, I had to pick up where the job ID is not null. So there are little different. The conditions of picking up is different. But this one, this table is the master table. And in this one is the master table. And this is less efficient because of the choice of the master table. So now you have an answer for 2B. I just wanted to do 3 because I wanted to show you step by step, which I could have done here too, but this way I'm showing you everything one by one, and then now I can put them together, right? Before I finish, just because it came to my mind, I saw something. This natural join, so in this B, where you said if field names are same and joining condition is equality, you can do this also. It just occurred to me. You can do what you were doing with the word inner join, but using. I'll write it here too. It's a C again. Instead of natural join, I'm still using inner join, but here instead of this where, you can say using. There's another one called using. What does using do? It's the same as natural join, but it says which field to use. Again, I must mention to you that it is entirely equality, same name. What doesn't it like now? Oh, with using, you have to use the word inner join. That's what it doesn't like. You cannot use comma. Can't use comma. With using, you cannot use comma. So natural join can be written like this also. You're using the word inner join, but you're using with it. So the where is replaced by using. Using title means title is equal to title. So for equality, and the field name has to be the same. So there are 5 solutions now instead of 4 for the first one. Right? So I want to do all 5 every time I do something with you. This is the first example I'm doing, so I'm showing you everything. Inner joins, comma, natural joins, Cartesian product, the using verb, the left outer join, the right outer join, and a subquery. But of course, and I'm not expecting you to answer 5 different ways in an exam also. Maybe in the assignment, yes, because you have time. That is practice. But in an exam, I'll only say use a left outer join, or use a right outer join, or use an inner join. Anyone, or maybe nothing at all. I leave it to you. You decide what you want to do. But in the assignment, there will be restrictions. Use an inner join, use an outer join, use subqueries. It will be very clear. Okay? Because I want you to practice. That's the whole thing. So here is another way where you are not putting the where, but you're using, but the restriction still remains the same. If the field names are same and joining condition is equality, exact match, including padded blanks. Or in other words, you can say padded blanks are not ignored. They're not ignored. You can find a solution of ignoring them. You can update it and then do it. You can always remove extra padded blanks. So there is another one. The word inner join has to be used. You cannot use comma, and you use the using verb. This is exactly natural join. Same name fields on equality. Lesser code. So if you see anything, you just do it. And I didn't write this because it didn't work in MySQL, but I should still give you it in comments. How I said intersect doesn't work, and I still gave it to you. I'll give you how except doesn't work and still give it to you. Here, the intersect. So when something is in a table and something is not in the other table, in English, you would expect you can say this. You would expect I could say this. Select the title from desired, except that they are not. That they are not in the other. But unfortunately, it doesn't work. So I mean, I can't do much about it, but we've written a solution. And also, for your information, there is a minus. There is a word minus also, and that also doesn't work. So you have except all same. duplicates and not duplicates, and you have a minus also. But none of these will work. And therefore, we had to write our own solution, which we did. We did it using right outer join. We did it using left outer join. We also did it using the subquery. So in MySQL, only union is available. Nothing else is available. So minus will make more sense to you. Minus just says subtract whatever you can and then leave whatever, right? So if a table has 1, 2, 3, 4, 5, and the other one has 1, 2, 6, 7, 8, 9, 10, it's saying subtract. So cut off what is common, leave what is not common. And that's what you wanted, right? But there is no way that I can prove to you that it works, because it doesn't work. I'll leave it there so that you have it, but I know you won't even pay attention to it because it doesn't work, which is fine. But if you're going to work in this field ever, there is a union, union all, intersect, intersect all, and there is an except, except all, and a minus in other relational databases. MySQL is a free one, so they don't have everything. But Oracle DB2 has everything. And then I gave you a solution which comes to your head immediately but is incorrect. Oh, she's saying do not match, let me just do a not equal to. This is an incorrect solution. So the only correct solution is using an outer join. So I showed you an outer join, a left one and a right one, but the choice of the master table is important. That's very important. When I tried it doing the other way, I couldn't figure out how to do it. There was no way because of how do I remove something. Here I said, oh, contact ID is null, but then I'm removing everything. So this solution was good for the 2B one. So I put it back in 2B for you so that you have it. I could have started doing it right from the beginning. I just wanted to just finish all outer joins with you, talk about it, and then give you the solution, right? So this is now complete. So you have been introduced to multiple tables in a database. You've been introduced to foreign key constraint today, and inner joins, Cartesian product, outer joins, and subquery. I still call it an introduction because there is a lot to do. So the next week and the week after, this is all we are working on. This is our job now, right? And while I work on them, I'll talk about normal forms when it arises. If it doesn't arise, then I'll do it as a separate lesson. But I think it should arise. Somewhere I will have a composite key, and then I'll talk about it. Okay? I'll put this on Blackboard for you. You can pick it up. And I don't know whether, oops, try again. That means my lesson recording is also somewhere in between. No, that's working. So how come Blackboard is not working? We are having trouble finding this site, it says. Let's try again. Okay, I'll remember to put it sometime else, maybe. Just it may not be just working now. I don't know.